Welcome to Civil Engineering Materials Lab. This is in Absent 1, room 112. My name is Daba Giddafa. I'm the chair and associate professor of Civil Engineering. I teach Civil Engineering Materials Lab. I'm going to provide the tour of this lab. And if you can follow me to show you the different setups we use for this lab. So this is the setup we use to determine the gradation of fine aggregates in the soil. For the soil part, I'm not going to come back to this station because now you already saw the setup we use. It is the same setup for fine aggregates and soil. So this is the setup we use to determine the gradation of coarse aggregates. Mostly the nominal maximum aggregate size for our materials is 3/4 of an inch, which means we start with number 1 sieve, then we go all the way to the pan. So the students use this information to mix their own concrete. So I will talk more about concrete mix design and the mixing and the compaction mix. So in addition to gradation, our students determine dry rotted unit weight of coarse aggregates, which is also needed for concrete mix design. This is to determine flattened elongated particles. This is mostly to design their own asphalt mix. Then our students use this setup to determine sand equivalent test. This is mostly for asphalt mix design. We use this setup to determine fine aggregate angularity. This is also an input for their asphalt mix design. This is a setup that is used to determine the specific gravity of fine aggregates. We also use to determine the specific gravity of asphalt mix, so I'm not going to come back later on. So we use the same setup to determine the maximum specific gravity of asphalt mixes after we crush the specimens. For the coarse aggregate specific gravity, we have a device at the back to determine the specific gravity for coarse aggregates. Once they determine all the aggregate properties, the students use those properties to design their own concrete in the asphalt mix. So this is just to make sure that they know what goes into the mix design. They do themselves to make sure that it is a real world scenario. So after they determine aggregate properties, they design their own concrete, then they mix their own concrete. They also determine the cement consistency, which is part of the concrete mix design. This is a Vickers apparatus to determine cement consistency. Then once the ingredients of concrete is determined, then we mix. This is one of the 3 mixers we have. This is the smallest one, so as a demonstration, but we have 2 larger mixers to avoid waiting time. Then students follow STM procedure to mix. Then once everything is mixed according to the procedure, then they dump into this wheelbarrow. Then they determine fresh properties of concrete. The first fresh property they determine is slump. So just to check the workability and the consistency of their mix. Once they determine the slump, then they determine the unit weight and air content of their fresh concrete. They also determine the temperature of the fresh concrete. So once they are done with mixing in the fresh properties of concrete, then they compact their specimens. So they make 4 cylinders for compressive strength and the tensile strength. Then they make 1 beam for flexural strength of concrete. So after 24 hours of curing, they remove their specimens from the mold and move those into this curing room. So the students keep their concrete in the curing room So it is running now since we have specimens on the shelf. So once they cure for 3 days or 7 days, depending on the curing period needed. During summertime, we just do for 3 days. For fall semester, we do 7 days, since we don't have a lot of time during summer. It is summer intensive. So after proper curing, we determine the hardening properties of concrete. Before we go to universal testing machines that can be used to determine hardening properties, let's finish the asphalt mix. So the students determine the properties of the ingredients for asphalt, then they design their own mix. Then once they are done with the mix design, then they mix compact. We have this triple Marshall compactor, and we have single. That means we can compact 4 specimens at a time. So once the students are done with compaction, then they use this one. We have 3 different setups to remove their specimens. These are the specimens they compacted this week on Tuesday. So we are going to test next Tuesday now. So next Tuesday, when they come to the lab, they are going to start with determining the bulk specific gravity of their specimens. Then they use this Marshall stability machine to determine the maximum load carrying capacity of their specimen, and also the flow number of their specimen. So this will be used to read the flow number. Once they are done with the stability and the flow number, then they break down the specimens into a maximum of 3/8 of an inch. Then they determine the GMM, which is the maximum specific gravity of their specimens. So once they have all those volumetric properties, then they can graph and determine if their mix satisfies all the criteria. Now I'm going to take you to the other room where we have 2 universal testing machines to determine hardened properties of concrete. So one of the equipment we spent about 142,000 almost 2 years ago now to reduce the waiting time for our students. Since the old machine is just, this one is a universal testing machine, which is relatively old. It can go up to 300,000 pounds. When you have 4 or 5 groups in the lab, so waiting time could be too much. So to reduce waiting time, we purchased the new universal testing machine for again about 142,000. Before we determine compressive strength of our specimen using universal testing machine, this or the other one, we first determine the compressive strength by using Schmidt-Hammer test, which is a non-destructive testing method. That way students have a good idea of what is the expected compressive strength of their specimen. Then they come to this. We always make sure that students wear safety glasses in this case. Even though we close this one for safety, we want to make sure that students wear the safety glasses and they stay away. Safety is a priority for all of us. And our students use safety glasses or gloves or any other type of personal protective equipment depending on the need. Sometimes they need eyeglass, sometimes they need gloves, sometimes they need both, sometimes hard hat, so whatever is needed is provided, and safety is a priority for all of us. All the students read the safety procedures or guidelines, which is a 2-page guidelines on the first day of the lab. Then they have to sign that, and we have an instructor and a graduate teaching assistant all the time with the students to guide them how to safely and efficiently use equipment. So this is about safety and also efficient use of an equipment. We don't want the students to break down the equipment. So this is the setup we use to test the tensile strength of concrete, flexural strength of concrete, and Poisson's ratio and modulus of elasticity, and also modulus of rupture or bending strength of concrete. We also use the same equipment to determine tensile strength of steel, compressive strength of steel. Then we also use the same equipment to determine compressive strength of steel in like wood or timber, and also flexural strength of wood or timber. So the students compare the compressive strength and the flexural strength of timber or wood and see in which one it will be stronger. So if it is compressive or flexural, and then they compare to the literature review. So in literature, it may say wood is stronger in bending, or it may say in tension. Then we want to make sure our students verify what they learn in the classroom, because that is the whole idea of the lab. And then they analyze their data and write a group report and an individual report to become an independent thinker and a team player. So that's all I got for the Civil Engineering Materials Lab, and if you have questions, please let me know at any time. Thank you so much.